Hello, it's been a long time since I last uploaded a video on this channel. And as usual, it will be practice for a talk I will give for my university because that's the only thing I do these days, kinda, because it keeps me so busy. Anyway, this time I'm maybe sure you've heard about it in the news, but there's a new Spinosaurus that has been found in Europe. And you might remember that like last year or so, I made a video about Spinosaurus where I discussed if it was aquatic or not. And you could see this video as a bit of an unofficial sequel to it. And yes, it's about an yet undiagnosed specimen of Spinosaurid from the White Rock Sandstone in England. And yeah. The first question is, of course, why am I making a video about this? What's the point? And why is it special? And there's 4 things about it that are notable. It's big, it's young, not in ontogeny, but more like in stratigraphy. It's younger than the other European Spinosaurids, and it's very mysterious, by which I just mean it's poorly preserved. It doesn't have a name. It doesn't have a specific diagnosis, and we'll later see why. And it might shed light on the whole debate if Spinosaurus was semi-aquatic or not, even if only a little bit. And yeah, it hails from the Isle of Wight, which, as should probably not be a surprise to you, is in England. And this formation has actually given us quite a few dinosaur species over time. You have, you know, over 20 species from about 132 to 110 million years in age. And this figure is from a paper that I'm presenting. And yeah, here you can see where the whole wheeling group is in England. Here's the Isle of Wight, which is very much in the south. And here you have London, here you have Wales. You can basically see where it is in relation to the rest of England. It's very much in the south. And one big part of it is the Wessex Formation. The Wessex Formation is a fluvial-lacustrine formation that has given us theropods, titanosaurs, ankylosaurs, ornithopods, and all other kinds of colorful critters. But it's not what this video will be about. Maybe I do a different video about the Wessex Formation. I won't, sorry. But we are going to talk about the Vectis Formation instead, which is about 67 meters thick and which is above the Wessex Formation. It's Barremian to Aptian in age. And unlike the more fluvial Wessex Formation, it's more full of marine and lagoonal influences. The White Rock Spinosaurid in particular, from which we got our candidate, is from the lowermost part, which is roughly the border between the Vectis Formation and the Wessex Formation. And Vectis Formation is a little bit meager. Is a little bit meager in terms of the fossils that it has given us so far. We don't have so many dinosaurs. We just have like Polacanthus or Hypsilophodon maybe, and but that's about everything. But well, that's not everything, but we haven't seen anything unique or spectacular so far. It's mostly just crackrays from ornithopods, theropods, pheropods, not notable until now. You know, we're going to talk about some bones which have been found in 2018 or sometime before, and this picture gives you some context on where it's been found. It's in this sandstone, which is in the very, very border between the Vectis Formation and the Wessex Formation. See here with the arrow, and the gray part is the Vectis Formation, and all the red part here is the Wessex Formation, and here's the White Rock Spinosaurid somewhere at the intersection. Yeah, and here you have it again. Here below, here's the sandstone, and here's the sandstone as you can see it. the gray is the basic summation, and here is where the Spinosaurus is actually found. And the bones belong to a single individual, likely Spinosaurus, although their exact subfamily isn't quite so clear yet. And we certainly have found British early Cretaceous Spinosaurids before. The classical example would, of course, be the Baryonyx, which you have here a reconstruction by the good old Scott Hartman. Yeah, I can't recommend his general skeletal reconstructions enough. And other more obscure taxa would be the Riparovinator and the Ceratosophops, which also have some restorations here. And all of those are closely related to the Baryonyx, which is interesting because you might think that the White Rock Spinosaurus is also a Baryonyx. It's also in the same subfamily as Baryonyx, but is he? We will see. So this will probably be a bit more boring part of this video, but I will have to talk about the bones. And we have some anterior parts of the dorsal vertebral column, and they preserve the majority of a neural centrum and part of a neural arc. And most of them appear to be either D2 or D3 in terms of their position. Oh, sorry for that sound. There is something you can say about the taphonomy. They have plenty of cancellous bones that's exposed around the dorsal surface, which indicates that it has been the victim of abrasion. And it could be that there was plastic deformation because, you know, with a parapophysis, it's being bent a little bit backward, which could mean that there were compressive forces that have acted on it. And we also have some sacral centra, which have mostly the central present, but there are no ribs or arches. And it's a little bit hard to say what kind of sacral exactly they are, because it's believed that at least in some theropods, that the like the number of sacrals is a little bit related to how fused they are. So it's thought that the first sacral vertebra also fuse earlier, so the ones that form first basically, but none of them are fused, so we don't really have much of a clue about their placement. And other than that, you know, we have the dorsals, we have the sacrals, and we of course have the caudals. And these are very tall in terms, and we know that they are anterior caudals. We can rule out that they are dorsals or sacrals because they have no hyposphere. And they don't have any chevrons either. If they had chevrons, they would likely be posterior caudals, but they're not, they are anterior caudals. And you should probably remember these guys because they are going to be very important for the phylogeny discussion that will come later. And then, you know, we had the dorsals with the sacrals and the caudals. We also have some parts of the appendicular skeleton, you know, the ilium. And yeah, the ilium, it's very fragmentary. So there's roughly few things I can say about it. It's large, it's fragmentary, and it's not pneumatized. That's, yeah. That's maybe something to remember about the aquatic Spinosaurus discussion, because we aren't sure yet to what degree Spinosaurus itself had pneumatic bones. And this is one piece of evidence that could maybe be taken into consideration to that whole discussion. And finally, the last type of bones we have are long bone fragments. And yeah, the paper had like one paragraph about them. So two things. It's not clear if they are even from the same element, but if they are, they're likely from the pelvis. That's all I can say. So now that we have the bare bones, if you forgive this terrible pun, we can go to the phylogeny. And how much can we tell about this phylogeny just from the bones alone? Well, the authors did a three-step reasoning process. First, they saw that there are neural arch fossa and delimitating laminae, which they took as characteristic criteria that it's likely a saurischian. Then they looked at the cervicals, which were opistocellus and pneumatic, and deduced from they looked, sorry, not the cervicals, as vertebrae in general, I think, which are both opistocellus and pneumatic, and they that we narrowed it down that it was likely a theropod. And finally, once you add the fact that it had so-called spinodiapophyseal webbing in its vertebra, we could narrow it down to a Spinosaurid. Easy, wasn't it? Well, maybe. We need to be a bit more precise. So they compared it, some of its bones, to baryonyx and Triparovinator, and they did a TNT analysis with roughly 41 operational taxonomic units and 1,800 characters. And since they were statisticians, they also predicted Barema support values and jackknife values from roughly 1,000 pseudo-replicates. So that's the technical nitty-gritty, and the question is now just what did they get? They got quite a lot of trees, actually, 4 different trees, and we'll look at them in more detail. First, there's the strict consensus tree, where absolutely nothing within the Spinosauridae is resolved. And this kind of shows how messy the group is, and it also, unsurprisingly, the white rock Spinosaurid doesn't have a particularly specific placement. So that's a bit disappointing, maybe. But we have a reduced consensus tree, which at least recognizes Spinosaurinae and Baryonychinae as distinct subfamilies. And the white rock Spinosaurid is closer to Spinosaurus than to Baryonyx, which, as I noted before, is very interesting. Because all the other English Spinosaurids so far are certainly more in the lower half of this tree than in the upper half. However, as you can see, if you see those jackknife support values, you can see that this placement is very weakly supported. And it's even possible that there is an unresolved polytomy or unresolved trichotomy, if this is the right word, where it's simply equally related to both, or we don't know to whom it's more closely related. Which is, yes, certainly an alternative. But let's assume, for example, that the reduced consensus is right. What is the significance? Well, it would be the first Spinosaurian of its kind in the early Cretaceous of Britain. And that would have some interesting biogeographic implications, because while Spinosaurians are not really known from England, we do know some of them that are from the Iberian Isles, so somewhere near Spain, which isn't so far from England. And it's actually possible that Spinosaurids might have evolved in Europe. So that definitely has biogeographic implications. But what is interesting is that it might not be all that. What is interesting is that all 3 of the Spinosaurian all of the 3 Spinopomorphies which I've used to place it within the Spinosaurians are related to the anterior caudal vertebra, which is why I said before that they are going to be important for the phylogeny. If you just look at this, these are the 3 characters which I just copy-pasted from the paper. Just pause this video if you want to copy them down. I won't discuss them in detail, but yes, the tail vertebra are kind of important in this phylogeny. But they might not be diagnostic. The anterior caudals in Suchomimus and Baryonyx are very poorly known. And characters might vary depending on the exact placement. Because, yes, characters might vary depending on the exact placement, which, and in many taxa, the placement isn't known, so it's kind of not known if the characters are even homologous. And there is some more notes, and it's possible that there are no megalosaurid taxa here, but it would be possible if you just add a few extra stats, and if you make some maybe unparsimonious assumptions, you could place it in the megalosaurids, because it has some features like enlarged pneumatic foramina that are megalosaurid synapomorphies, but the preservation is a problem. Also, it's also been noted that you could use the I think it's also been noted in the paper that you could use the caudal elements to place the dropper close to the parognathor, which I personally didn't quite understand, because it also said that the caudal elements was what put it in the Spinosaurids in the first place. But yeah, that's apparently how it is. Like, there is apparently a case to be made that it could also be in the Baryonychinae, but yes, the Spinosaurinae is the interpretation which the authors just rolled with. And like I mentioned before, a lot of the problems that we have with this dinosaur is that it's just very poorly preserved. And there are some more details about this. The surface markings are cracked, crazed, irregular, and the sacral centra even show longitudinal cracking. And what could be causes? Why is it so bad? Why is it so poorly preserved? And there could be multiple causes. It could just be weathering and abrasion, and based on the stages of abrasion, it's possible that it was exposed about 3 to 4 years to the elements before it got buried, which makes sense, because if with rapid burial, I think we would have found more bones. And it's also possible that in this time it just got trampled on. And there are these tubes which are here marked with the letters TU, and they are very interesting because they're probably biologic in nature and the work of invertebrates. And there have been similar borings in other animals in the Upper Jurassic and early Cretaceous, and based on the length and weight of the borings, it's possible that beetles of the order Coleoptera are the culprits. Which, fun fact for those who are interested, my master's thesis is about Coleoptera beetles. So when I first got the topic, I thought that, oh no, I want to be a dinosaur person, but beetles and dinosaurs, they do sometimes interact, you see. And from statistics alone, it's possible that it were Demestia narvi, because there's just some of the most common invertebrates that love gnawing on prehistoric bone. They're just really common in these types of areas. And then there's the fact that they have those cement matrix and fillings, which implies that the borings happened before the burial actually took place. And yeah, there's some more evidence that beetles are the ones who did this instead of other insects, and beetles are just common in the weeded supergroup in general, and other possible insects like Hymenopterans or Rhizopterans just don't produce tunnels. Their larvae produce a bit other structures. And like Demestians in particular use tunnels for pupation, and they're most likely to do it in the bones when the muscles are not available and when we're starved. So this has some interesting notes on the paleo environment. Like, you can imagine that there wasn't much water for a long time while the dead animal was somewhere in the desert or something before it got washed away. That's what could have happened. And the consequences of bioerosion are just that this guy just can't be diagnosed so well. He will be forever without a name, or maybe not forever, but he will be without a name for a while, and this is very sad. But if I'm honest, I'm being a bit tired, and I would just want to close this talk after a while. So now comes the million-dollar question, that is, like, it's why do we read papers about big theropods? What interests about them? And I'm a simple man. When I see theropods, the main thing that interests me is that I just want to know how big it was, okay? And let's compare it to the current record holder. We have a megalosaurin caudal vertebra that has the catalog number MUJA line 1913. Its estimated length is above 10 meters, and it has a caudal vertebra with a dorsoventral height of 150 millimeters. That's cute, isn't it? White rock Spinosaurid has the same bone, only roughly 10 millimeters longer. And for comparison, if you think I'm cherry picking, the Spinosaurus holotype had a bone that was roughly had the same bone in roughly 25 millimeters shorter. Or at least we think it was the same bone. And I'm pretty sure the Spinosaurus holotype was also within the 10 meters bracket. So I'm personally not the type of sensationalist who loves estimating an animal's size and say this is super big from just a single bone. There's always fluctuations here, but I think it's likely to say that it was a big animal, likely above 10 meters. So roughly within the, how did the old children's book say it, roughly as big as a school bus. And that brings us back to the question if Spinosaurus was semi-aquatic or not, for those who just love listening to my talks in general, because I just keep coming back to it, because the white rock Spinosaurid gives us a little bit of an insight on it, because some authors have suggested that Spinosaurids became semi-aquatic as an adaptation to bigger body size. Because they got so big and it was easier to carry their weight in the water, they turned semi-aquatic when they became big, when they reached the 10 to 50 meters size bracket. White rock Spinosaurid is certainly within its size range. But it doesn't have any sort of obvious semi-aquatic adaptations. Like I said before, its bones were likely pumatized, and it just lacks dense long bones. Like, I know it's fragmentary, maybe it had some aquatic adaptations which we don't know about, but the fact that it has dense long bones is a pretty big problem. Because normally you would expect an animal that's diving like a crocodile to have more body density in order to just sink in water. So this piece of evidence itself is a small puzzle piece which supports the conclusion from my last talk that Spinosaurus was likely more of a crane than a crocodile. But like I said, it's a fragmentary animal. It's just one small piece of evidence, and the authors didn't really do anything. And the authors didn't really discuss this in much detail, because there has unfortunately been no histological analysis on the bones so far, which is very sad. It's definitely something I'd have loved. I don't know if this animal had been discovered a little bit earlier, some months ago, maybe this is something I would have done, like to do for my master's thesis, even though it would probably not have been possible to get the bones or anything from that. But you know, one can dream. I at least hope that there will be some more histological analysis on it later, because like we saw in the Spinosaurus talk, this is the sort of thing that would be interesting to see what growth patterns it has and if they are similar to a sea cow or anything. Because that could absolutely help us in this discussion, but we don't have this, and the authors themselves admitted that in order to discuss if the white rock Spinosaurid was semi-aquatic or not, we would need a whole paper on the subject, and this is simply beyond the scope of this talk. So, what are the conclusions? It's likely among the younger European Spinosaurids, but the sheer fact that it's a Spinosaurid in Europe has some biogeographic implications which are interesting. It was big, it was poorly preserved, it doesn't have a name yet, it was likely terrestrial, and its phylogeny stands on very shaky legs. That's, yeah, I personally can't wait to learn more about this creature. I hope there will be more papers about it. I hope it will get properly diagnosed later. And that was the talk, that was the video, this is the paper I introduced to you. I hope you enjoyed it. And if you have any, no, I'm not giving a talk. This is my video. If you like it, please hit the subscribe button, leave a comment, give me a thumbs up, even though I know YouTube doesn't show thumbs down below, and tell me what you think.